Okay, Alan. Let's start. So we are going to start this topic, and am I audible clearly? Alan, Alan, are you there? Alan, are you there?
Yes, sir.
Okay. So we are going to start this Henry's law. See what is Henry law? And Henry law is basically the solubility of gas in liquid is directly proportional to the partial pressure of that gas above liquid surface. First of all, solubility. Henry took the solubilities unit in terms of mole fraction. In terms of mole fraction. So you have seen this. If you have taken, just take an example of dew. This is the bottle of dew, cold drink. So you know that when you are going to open this and this is full of dew. So when you are going to open it, there will be some gaseous particle here that will be applying force on the liquid, that will be applying pressure on the liquid part. That pressure is directly proportional to the solubility of this gas in liquid. This is according to the Henry's law. So we can directly write solubility of gas directly proportional to the partial pressure of gas above liquid surface. Partial pressure of gas of that gas above liquid surface. So we can also write it like this: partial pressure of gas above liquid surface directly proportional to solubility of gas in liquid, solubility of gas in liquid, in that liquid you can say. Now I'm going to denote this partial pressure with P, which is directly proportional to the mole fraction of gas above liquid surface. And to remove this proportionality sign, we are going to take a constant that is known as Henry's constant, and this is your mole fraction of gas. So this is the formula we get from Henry's law. This is your mole fraction of gas. So see, what is this kh? Kh is basically Henry's constant. This is your Henry's constant that depends upon nature of solvent. Henry's constant. So if you are going to find the value of kh, that will be equal to pressure upon mole fraction of gas. And we know that the unit of mole fraction is unitless, P is pressure. So unit of this will be atm or bar. Unit of kh will be ATM or bar. That totally depends upon this pressure. That totally depend upon this partial pressure, because mole fraction is unitless. And if we are going to plot a graph between pressure, partial pressure, and mole fraction of gas in liquid, then you can see these are directly proportional. So the graph will be a straight line. The graph will be a straight line. And if you are going to find the slope of this slope, that means basically tan theta will be equal to perpendicular upon base. And you know, this is your perpendicular, that means P is the perpendicular and base is the mole fraction, that means P upon mole fraction of gas. So the slope of partial pressure of gas versus the partial pressure of gas versus mole fraction of gas will give you KH. That means slope of this graph give us Henry's constant. Give us Henry's constant. Anushka, are you there?
Yes, sir.
Okay, I'll just slide it up and explain it to you. Alan, just let me know so that I will.
Yes, sir.
Okay. So Anushka, we just started with this Henry's law. What is Henry's law? Henry's law is all about mixing or making a solution of liquid and gas. Now, what does Henry's law say? It says that solubility of gas in liquid is directly proportional to the partial pressure of that gas above liquid surface. You know that this is your soft drink, and if you are going to open this bottle, what you will see, there will be a sound like this, and basically there is gas above this liquid surface. That gas will be applying partial pressure or applying pressure to this liquid. So this partial pressure of gas will be directly proportional to the solubility of this gas to this liquid. So according to the Henry's law, this is the scenario: solubility of gas is directly proportional to the solubility of pressure of that gas above liquid surface. And we can reverse this, because if A is directly proportional to B, that means B is directly proportional to A, and we can write this. To remove this proportionality sign, we can put the value of Henry's constant. This is the formula for Henry's constant. Please do write it or take a screenshot and let me know.
Sir.
Yes.
Sir, in exams, this question is very common to ask when in this Henry's law context. Why do fishes prefer cold water than hot water? So,
We will come to that. We will come to that. Don't worry.
yes.
Actually, this phase question that will be solved, I will be asking the same question. It is based upon the last concept that we have studied, effect of temperature. Basically, the dissolution, that means the dissolution, mixing of or solubility of oxygen in water is your exothermic process. Are you getting my point? The mixing or solubility of oxygen from atmosphere in water is an exothermic process. And in summer, what do you think? This is the exothermic process, and in summer, temperature rises. So if the temperature rises, the solubility of that oxygen in water will be decreases. So basically, proper amount of oxygen does not dissolve or soluble in that water. That's why they feel uncomfortable. But that thing in winter, you can see exothermic process. So if you are going to decrease the temperature, that happens in winter, solubility increases. So they get enough amount of oxygen. That's why they feel comfortable in cold water as compared to hot water, or you can say they feel comfortable in winter as compared to summer. Is that clear, Anushka?
Yes, sir.
Okay. Just let me know when you are done with this. Are you done with this?
Yes, sir.
Okay. Now moving to this is the Henry's law. Please take a screenshot of this. Have you written the graph as well? Since partial pressure directly proportional to the mole fraction, so the graph will be a straight line. Then
Can you repeat what you said? Your voice was breaking, so I couldn't hear what you just told.
see, if you're going to plot a graph between partial pressure and mole fraction of gas in liquid, it will be a straight line. It will be a straight line because they are directly proportional to each other, and it will start from origin. It will start from origin because if there is no partial pressure, there will be no mixing. So if you are going to calculate the, if you are going to see the slope that means tan theta, that means you have studied this in class 10th trigonometric, tan theta perpendicular upon base. This is your perpendicular and this will be your base. So perpendicular is P pressure, partial pressure, and this is mole fraction. This is what? This is your equal to kh. Kh, that means basically Henry's constant. So all I want to say is that the graph of partial pressure versus mole fraction of gas in liquid will be a straight line passing through origin, in which the slope of this graph will give Henry's constant. Anushka, is that clear?
Yes, sir.
Okay. Can I change the slide?
Yes, sir.
Now moving towards the vapor pressure, that means basically moving towards the Rod's law. So first of all, what is vapor pressure? So you know that the pressure exerted by vapor or water vapor in our day-to-day life we see, uh, this is common, water vapor. So the pressure, write with me the definition. The pressure exerted by vapor. The pressure exerted by vapor is called water vapor. Is called is called vapor pressure. Is called vapor pressure. Now, this is very important. I'm going to show you. This is a container. This is a container in which, just suppose, a liquid or water is present. Water is present. See, the liquid which is present here or below the surface are known as bulk molecules of water. And the liquid which present on the surface are known as surface molecules, Now, what you are going to do, you are going to uh, give heat to this. You are going to give heat to this. That means you are boiling it. You are boiling it. So after some time, if you are saying that this is water, if I'm saying that this is water, so it will start boiling or it will start converting from liquid to gas, right? From liquid to vapor. Are you getting my point? Alan,
Yes, sir.
Anushka. So, what do you think? Which molecules will evaporate, or which molecule will be vaporized first? The surface molecules or the bulk molecules?
Molecules.
This is the
For the
concept. Very,
surface molecules.
what you just said, Alan.
Surface
What's
molecules.
your answer? Surface molecules? Very good. So basically, why does this surface molecules evaporates or vaporize first than the bulk molecules? Why does so?
Sir, since it's like just above it's directly in contact with the
Atmosphere?
atmosphere, that's why it gets.
It's not. It's not. It's not like that. Alan, I want more chemical answer. Alan, why does it vaporize first? Is there any answer? If you not, just let me know.
Yes, so the partial pressure is directly proportional to the mole fraction. So since it's directly in contact, it will evaporate faster.
No, you cannot apply the Henry's law here. Henry's law is solubility of gas in liquid. And here, what we are studying is there is no gas. We are boiling it. What I want to say is that if you are going to boil water, will there be any mixing or solubility of any gas to that? Basically, you are going to heat it, you are going to boil water. So this water will be converted into what? Gas. See what happens in evaporation. This is the correct answer. In evaporation, surface molecule, the answer that you have given, surface molecules evaporates. Surface molecules evaporates. Actually, all the surface molecules once was a bulk molecules, and they get energized first. Basically, when you are going to give heat energy to that molecule will get energized, and when they will get energized, that energy will be converted into kinetic energy, and they will start moving. And if they are moving with a fast velocity, so the force of attraction decreases and they reach on the surface and then evaporates. So basically, all I want to say is that this is the answer that you have given me, and the reason behind it, they have higher kinetic energy, they have higher kinetic energy, and then low force of attraction. They have low force of attraction. That's why they evaporate. Is that clear?
Yes, sir.
Anush, okay. Can I change the slide? Just let me know.
Done, sir.
Hello.
Yes, sir.
Very good. Now see factors on which vapor pressure depends. Factors on which vapor pressure depends. The first one is it does not depend on shape or size. Shape or size of container. If you are going to boil water in a cylindrical container, it will boil at 100 degrees centigrade. If you are going to take a conical container, it will boil at 100 degrees centigrade. It doesn't depend upon shape and size. The second, it depends upon substance. It depends upon nature of substance. So how it depends upon nature of substance? For that, you have C2H5OH, you have C2H5OH and H2O. So you will see that of C2H5OH, the vapor pressure. Am I audible clearly?
Yes, sir.
Alan, am I audible clearly? Anushka?
Yes, sir.
See, this is what you will see. The vapor pressure of C2H5OH is greater than vapor pressure of water, because in water we have four hydrogen bond. We have four hydrogen bonding. One molecule of water will make four hydrogen bonding, and here hydrogen bonding will be there, but lesser than water, lesser hydrogen bonding than H2O. So if there will be more hydrogen bonding, force of attraction will be more. Force of attraction will be more, and that's why it doesn't easily evaporate it. But this will be evaporated easily only because the hydrogen bonding is lesser. And if the hydrogen bonding is lesser, that means force of attraction between the particle is lesser, and hence it can be easily evaporated. Is that clear? So we can also write vapor pressure inversely proportional to force of attraction and inversely proportional to boiling point as well. If the vapor pressure is directly proportional, if the vapor pressure is inversely proportional to boiling point, that means if a substance is having more vapor pressure, that means it will have lesser boiling point. That means the boiling point of C2H5OH, that means ethanol, will be lesser than the boiling point of H2O. Please do write it and let me know. Let me know when you are done with this. Anushka, Alan.
Yes, sir.
Okay. Arranging. Increasing order of boiling point. C2H5OH is there. This is your ethanol. Then comes your CH2H and then your CH2OH. This is your glycol. Then comes your CH2OH, CHOH, and CH2OH. Glycerol. In which the vapor pressure will be Alan, is there any answer?
So ethanol less than glycol less than glycerol.
Which one will be the high boiling point I wrote?
Yes, boiling
I
point
should,
will
I, sh-
it'll increase from 1 to 3.
okay, wait a minute. Vapor pressure, we should concentrate right on one vapor pressure. Which one will have the
Glycerol.
more vapor pressure? See, there will be more hydrogen bonding. So force of attraction increases, vapor pressure
Yeah.
decreases. So this will be the answer you had calculated for BP boiling point was correct.
Okay, yes, sir.
Yeah. Anushka, what about you? Anushka, are you done with this? Okay, very good. Now moving to the next, that is substance. Substance. See, there are two types of substances. The first one is volatile. The second one is non-volatile. As you can see, vapor pressure is not equals to zero. The substance which is volatile will create vapor pressure, and the substance which is non-volatile will not create vapor pressure. So vapor pressure will be equal to zero. Example of volatile substances will be equal to H2O, C2H5OH, CH3OH, etc. Now, if you are going for this non-volatile substance, then urea, glucose, sucrose, etc. is the non-volatile substance. Now, vapor pressure versus temperature. If you're going to plot a graph, the graph will be like this. This is the graph between vapor pressure versus temperature. Please do write it. A temperature will come where all the substances will be converted into vapor. Okay, very good. Just let me know whenever you are done with this. Thank you. Now moving to the next topic, which is vapor pressure of solution containing two volatile liquids. Vapor pressure of solution containing two volatile liquids. This is a container. Both the liquids are volatile. That means the solute and solvent are volatile. And let's say only AA is present in this container. Only AAA is present in this container. So here we can call it pure liquid A. And only here B is present here. And that is pure liquid B. Pure liquid B. Now, as you can see, this will be equal to P naught A. And P naught A, whenever there will be naught, that means pure. So P naught A is the vapor pressure of pure liquid A. And here, since B is also pure, so we represent it by P naught B, and we can write vapor pressure of pure liquid B. And you can see there is a bigger container. You are going to mix this solute and solvent. So it will be like this. They will mix up with each other. A, B, A, B, A, B. And here, whenever more than one substance is present, then we say PA and PB. And basically, PA, whenever more than one substance is present and there will be pressure, we say partial vapor pressure or partial pressure. Partial vapor pressure, VP stand for vapor pressure of A, and PB is partial vapor pressure of B. Partial vapor pressure of B. Please do write it. Before writing it, can you tell me what is the mole fraction of A in this container and mole fraction of B in this container? Mole fraction of B in this container is 0 because no B is present. There is no molecules of B. And mole fraction of A is 1 because mole fraction of A will be number of moles of A upon total number of moles in the container. Both are A, so 1 by 1 it will be. Mole fraction of B here will be A, and mole fraction of if you are going to calculate A, it will be 0 because there is no number of moles of A in this container. Is that clear? Alan, Anushka.
Yes, sir.
Okay. Now, for this concept, I'm going to introduce Rawls law. Rawls law. So write with me the Rawls law. So according to this law, according to this law, in a solution, partial vapor pressure of each component is directly proportional to mole fraction of that component. Mole fraction of that component. So basically, what does this mean? Partial pressure of each component. If I'm going to take A, partial pressure of A will be directly proportional to mole fraction of that component A. To remove this proportionality sign, I'm going to use a constant K. Then we will see what is K. K is constant. Please do write up to this. Then I will tell you what is K. Are you done with this, Alan? Okay, thank you. Now
No,
see.
sir. Just a second.
Okay.
Yes, sir.
What is this K? We can derive this easily. If A is pure, that means if A is pure, the mole fraction of A will be equal to 1, because you know that if you are going to calculate mole fraction of A, that means number of moles of A upon total number of moles. So number of moles of A will be Na, and total number of moles in the container is also Na. So this will be cancelled out to be Zeta. And whenever this is pure, the partial pressure will be equal to P naught A. Yes or no? Please do let me know. So I am going to put the value of mole fraction zeta A equals to 1. So PA will be equal to K, and you know that when it is pure, the pressure will be equal to denoted by P naught A. So this is the value of K. So we got a formula: partial pressure of A will be equal to pure pressure of A into mole fraction of A. In the same way, you can calculate the partial pressure of B will be equal to pure pressure of B into mole fraction of B. So this is what Rawls' law says, that the partial pressure of each component will be directly proportional to the mole fraction of that component. And if you are going to remove this proportionality sign, you can directly put the value of pure pressure of that component. Are you done with this? Very good. Now, you know that if in this container PA and PB is present, partial pressure of A, partial vapor pressure of A, partial vapor pressure of B. So total pressure will be equal to the sum of the partial pressure. And PA can be written as P naught A zeta A plus P naught B zeta B. Is that clear?
Yes, sir.
So I'm going to give you a question. Please do write it. It's very easy. You just need to focus on the mole fraction and find the value. If 0.78 gram of benzene, that means C6H6, and 0.92 gram of toluene, that means C6H5CH3, are mixed. Find partial pressure of benzene and toluene, and also total pressure of solution. Total pressure of solution. If pure vapor pressure of benzene is equal to 400 mmHg, and pure vapor pressure of tolving, a small t stand for tolving, is equal to 200 mm. Now, please do it. Alan, are you done with this? Anushka, are you able to solve it? Anushka, you are not audible. Are you done with this, Anushka? Okay. Anushka, are you done with this? Okay.
Sir, partial pressure 94.
Yes, Alan, what was your answer?
Partial pressure is 94 millimeter per hour. It's
For what? Partial pressure of which?
of benzene.
94 or 90? Okay, let me explain it. So if you are, you can see mass of benzene is
No,
given
sir,
zero point
so,
0.7.
no, partial pressure toluene is 94.
Okay, I will check it. Mass of benzene is 0.78 gram and mass of toluene is 0.92 gram. It is also given that pure pressure of benzene, wait a minute. Yes, so this is given, only this is given. So if you are going to see, am I audible to you? Anushka,
Yes,
Alan.
yes, sir.
So we need to calculate the partial pressure of benzene, which will have a formula, pure pressure of benzene into mole fraction of benzene, right? This will be the formula. Now we need to, since we need to calculate the partial pressure, this is given in the question, but we need to calculate the mole fraction of benzene. And for mole fraction of benzene, we need to have the number of moles of benzene as well as toluene. So I'm going to calculate the number of moles of benzene, which will be equal to given mass upon molar mass. Given mass is 0.78 and molar mass. What is the molar mass of benzene? Can you tell me, Alan? Molar mass of benzene, if you are going to take, it will be
78, sir.
78. So if you are going to remove this decimal, it will be 78,
0
78 will be
0.01.
cancelled, 0.01 mole. This is the number of moles of benzene. If you are going to calculate the number of moles of toluene, it will be given mass, that is 0.92 upon molar mass, that will be equal to 92. So basically it will be equal to 0.01 mole. This is the number of moles of toluene. Now we can easily calculate the mole fraction of benzene, that will be equal to number of moles of benzene upon number of moles of benzene plus number of moles of toluene. Now as you can see, number of moles of benzene is 0.01 upon 0.01 plus 0.01. So it will be equal to 0.01 upon 0.02. If you are going to calculate it, you will get the mole fraction of benzene as half. Now we can easily put the value here. What is the pure vapor pressure of benzene? That is 400 mmHg. And what is the mole fraction of benzene? That we got 1 by 2. So the partial pressure of benzene will be equal to 200 mmHg. Is that clear? So this is the formula from Rolle's law. Now, as you can see, partial pressure of toluene will be equal to pure pressure of toluene into mole fraction of toluene. Pure pressure of toluene is given as 200. Now we need to calculate the mole fraction of toluene, which will have a formula, number of moles of toluene, which we have already calculated, 0.01 upon 0.01 plus 0.01. So it will be again 1 by 2. And you can see this, we will get 100 mmHg. Mole fraction of partial pressure of toluene will be equal to 100 mmHg. Now, in order to calculate the total pressure of solution, this will be equal to partial pressure of benzene plus partial pressure of toluene. Partial pressure of benzene is 200 and mole partial pressure of toluene is 100. So it will be equal to 300 mmHg. This is the answer. Have you got this?
I got 210 and 94. So I think it is some calculation mistake.
What you just said?
Yes, I approximately got the same value.
Okay, okay. Anushka, what about you? Okay, can I change the slide? Oh. Now I'm going to You draw a graph, which is very important. This graph is basically for ideal solution, or you can say this applies to the Rawls law. So now here is your mole fraction of A, that is equal to 1. That means pure mole fraction. So it will have P naught A. And here your mole fraction of B is equal to 1. P naught B. Mole fraction of B is equal to 0 and mole fraction of A is equal to 0. Now since they are directly proportional to each other, so we just did this. Basically the graph is in between vapor pressure versus mole fraction. Vapor pressure versus mole fraction. So see, this is your PB, that will be equal to P naught B zeta B, and this is equal to PA P naught A zeta A. And if you are going to add this point, this will be your PT, that will be equal to PA plus PB. Please do write. Are you done with this?
Yes, sir.
Okay. Now I'm going to give you another question on this. Just wait a minute. There is methanol and ethanol. If methanol has 3 mole and ethanol has 1 mole, wait a minute. Let me see the question. There is a little bit confusing. Yeah, no confusion. And P naught M is equal to 60 mmHg. Pure vapor pressure of methanol is 60 mmHg. And P naught E is equal to 84 mmHg. Calculate partial pressure of methanol and ethanol, and also total vapor pressure. Let me know when you are done with this. Are you done with this?
That's a 22.7.
Very good. First, you need to calculate the mole fraction of methanol, which will be equal to number of moles of methanol upon total number of moles, that will be equal to 4, 3 plus 1. And if you are going to calculate the mole fraction of ethanol, that will be equal to 1 by 4. Now, in order to calculate the partial pressure of methanol, we will have a formula, pure pressure of methanol into mole fraction of methanol. What is pure pressure of methanol? 60 into mole fraction of methanol will be equal to 3 by 4. So it will be 4, 15 just 60, 45 mmHg, 45 mmHg. And if you are going to calculate the mole fraction of ethanol, then it will have a formula, pure pressure of ethanol into mole fraction of ethanol. And this has a formula that this value is given, and which has a formula 1 by 4, right? So it will be equal to 84 divided by 4, that will be equal to 21 into 1, 21 mmHg. What was your answer, Alan? So if you are going to calculate the total pressure will be sum of the partial pressure. Anushka, have you got the answer? Okay. Anushka, no, I got the same answer. Okay. Sakina, are you there?
Yes, sir.
So you joined late, right? Alan and Anushka, this is it for today. If you want to be here, in the next class, we are going to have the type of solution, ideal and non-ideal solution. Okay. So, Sakina, we started with Henry's law, and Henry's law says that basically it is about solubility of gas in liquid. So the solubility of gas in liquid will be directly proportional to the partial pressure of gas above liquid surface. So from here we got a formula this. Yeah, can you take a screenshot of this, Sakina?
Yes, sir. Just a minute. Yes, sir, done.
So you can see there is a formula of P partial pressure that will be equal to Henry's constant into mole fraction of gas to remove this proportionality sign. And if you are going to plot a graph between partial pressure and mole fraction, the graph will be a straight line because they are directly proportional to each other. Okay. Also, the important point is that the slope of this graph will give you Henry's constant. The slope of this graph gives you Henry's constant. This is very important. Please do write. Take a screenshot of this. Are you done with this?
Yes, sir.
Now we started vapor pressure. See, vapor pressure is the pressure exerted by vapor that is called vapor pressure. This is a container in which water is present or any liquid. If you are going to heat it, it will evaporate or convert itself into gas or vapor. So there are two types of molecules: surface molecule which present on the surface and bulk molecules which is present below the surface molecule. And in these two types, only the surface molecule evaporates. Whichever is on the surface, that will evaporate because of two reasons: they have higher kinetic energy and lower force of attraction. Okay. So this is all theoretical. Please just take a screenshot, or if you want to write, you can.
Sir, what is FOA?
Force of attraction.
Okay. Yes, sir, done.
Very good. Now, the next is factors on which vapor pressure depends. So there are two factors. The first, it doesn't depend upon any shape or size of container. That means basically, if you are having a cylindrical container, the water will boil or convert itself into vapor only at 100 degrees centigrade. And if you are taking a conical container, it will boil at 100 degrees centigrade. This only depends upon nature of substances. That means basically, if the particles or the substance is having more force of attraction, then lesser vapor pressure, less force of attraction, then more vapor pressure. As you can see, vapor pressure of ethanol is greater than vapor pressure of water because water is surrounded by more hydrogen bonding. That means more force of attraction, and in ethanol less hydrogen bonding. That means force of attraction is lesser, so it will be easily converted into vapor. So vapor pressure is inversely proportional to force of attraction, or you can say vapor pressure is inversely proportional to boiling point. You cannot write boiling, please do write this. Or you can write it, not a problem.
Yes, sir, done.
Done. Now, there is a question: arrange in increasing order of vapor pressure. So see, there is one OH group from here. It will having hydrogen bonding. Here it will having two side hydrogen bonding at two sides. Here there will be hydrogen bonding from three sides. So if there is more hydrogen bonding, force of attraction more, vapor pressure less. So this ethanol will have the most vapor pressure, then this glycol, and then glycerol. Is that clear?
Yes, sir.
Can you change the slide?
Yes, sir.
No. say substances are of two types, volatile and non-volatile substance. Volatile one, which create vapor pressure, that means vapor pressure is not equals to zero, and non-volatile is the one which does not have exert any vapor pressure equals to zero. Example this and this. And the vapor pressure and temperature has a graph that is like this. A temperature will come when every substance, all the substance will be vaporized. Let me know when you're done.
Yes, sir, done.
Now, vapor pressure of solution containing two volatile liquids. Both the liquids are volatile. That means both the liquids will apply vapor pressure. So this is your pure vapor pressure. That means only see, this is your solvent and this is your solute. Now only A is present. That's why pure liquid A, pure liquid B. When it is pure, we represent it by P naught A, vapor pressure of pure liquid A, vapor pressure of pure liquid B, and then mixed in a bigger container. And whenever more than one substance is present, then we say partial vapor pressure. So it will be partial vapor pressure of A and partial vapor pressure of B. And here mole fraction of A will be equal to 1 because only A is present, and mole fraction of B will be 0 because there is no B, and mole fraction of B here will be 1 because only B is present. Mole fraction of A will be equal to 0 because no A is present. There is no. Please do write it. Are you done with this?
In just a minute, sir, doing. Sir, done.
Here comes the Rawls law. According to Rawls law, in that container, bigger container in a solution, partial vapor pressure of each component, let's say A has a partial vapor pressure PA, directly proportional to the mole fraction of that component Zi. To remove this proportionality sign, we kept a constant K, and this constant K will be equal to pure vapor pressure of A. So PA will be equal to P naught A into Zi. PB will be equal to P naught B Z.
Sir, done.
Okay. Now, this partial vapor pressure PA and PB, if you are going to add them, there will be this. PT will be equal to PA plus PB, and we know PA is equal to this and PB is equal to this. Just take a screenshot with this question and you will practice at home. And in the second question, you were here. So I will see you in the next class. Will you be available on Friday?
Yes, sir. Sir, actually, I wanted one-to-one
Your
session
voice
for
is
organic.
cracking. Your voice is cracking. Can you repeat it again? Uh, Your voice is cracking.
Sir, can you hear me now?
Yes, yes. Sakina, you are not audible. Can you write it in chat box? Sakina, are you there?
Yes, sir. Can you see the message, sir?
Oh, wait a minute. No, I didn't get any message. I think you have sent it to Learnivio.
Sir, can you hear me?
Yes, I can.
Okay, sir. I wanted help in organic.
Okay, no problem. Now, in which chapter?
Sir, the thing is, I know the chapters, but when I try to solve the questions, I'm not able to.
Okay, so I will tell the management or coordinator to arrange some classes from starting haloalkanes, or is it some other chapter?
Sir, hello.